Is it audible to you, students? I- if it is audible, then you can raise your hand so that I'll come to know, because I cannot. Yes, thank you NTC. And which is this other campus? Okay, how many campuses are online, sir? सगळे कॅम्पस ऑनलाईन आहे? सगळे कॅम्पस आहेत का म्हटलं? थँक्यू. Good afternoon once again. Let me introduce first of all to you people. Let me introduce me. I'm Harshawardhan Bhosale, working as an assistant professor at JSPM's Imperial College of Engineering in Computer Engineering Department. And today, as you can see the slide, we'll be discussing about multiple access protocols. Is the slide visible to you people, students? Yes. Every time I ask you the questions, either you will have to say yes. How will you say no? No with both the hands. Okay. Then yes. Thank you. Well, today we'll be discussing multiple access protocols from the first unit of cyber forensics and cyber applications. Basics of computer networking. You can see the name of the unit on the slide. Multiple access protocols. So let me go to the first slide so that we can start with the first point. Well, before we really start with number of multiple access protocols, let me tell you the purpose of having multiple access protocols with us, medium access protocols that we call it as. Because if you see, if there is a dedicated link in between the users, if there is a dedicated link present in 2 nodes, 3 nodes, 4 nodes, that is a physical connection, you can say, by using Cat3, Cat5 and Cat6 cables, then there will not be any problem to access the media, because in between 2 nodes, one dedicated link is already been given. But if it is a wireless communication, where there is no dedicated link, and you can understand that because you might have used some Wi-Fi connections, you might be using your Bluetooth connections and all. In that case, if you consider the computer networking where the wireless communication is being used, number of stations, number of nodes will be competing for getting the access to the media. And I believe some of the faculties from these different branches, these different campuses, they must have completed the same thing already. But you people can consider it as a revision once again before you go for your examination. So should I continue with the points, students? No? Yes, thank you. The student sitting on the first row, you can also answer me with this and that from all the campuses. And I'll try my level best to make it more interesting. I assure that it will not be boring stuff. And if you know something, then please let me know so that I can go to the next point. And if you have some doubts and questions with you, you can directly ask me from your point. Just ask your faculty to provide you the mic. So the very first slide you can see there, it's a data link layer. By the way, how many layers are there in OSI model, students? Third year students? Okay, nobody is answering. Hello, is it audible? Is it audible? Yes. How many layers? 7. Yes, there are 7 layers in OSI model. And in TCP/IP? Okay, JSCOE, the students are not answering anything from JSCOE campus. Yes, students. Sitting on the first row, some of the students sitting. Yes, I know that you cannot answer and I cannot listen to you, but at least you can show me the, yes, JSCOE students. I can understand. You can say 7, you can say 5, you can, yes, thank you very much. Otherwise it will be only one-way communication. I can see you people, but I know you cannot talk to me directly. So in this is the layer where multiple access protocols have been used, and this is a data link layer. If you see in data link layer itself, we have two layers. First one is a data link control, that is logical link control layer, and the second one is multiple access resolutions. I mean multiple access protocols will be here at this layer. See, if there is a, as I said already, if there is a dedicated link provided in between 2 users, in between number of machines, you don't need to use multiple access protocols. Directly dedicated link will be used for transmitting the data from one machine to another machine. But if there is no dedicated link, if you are using wireless communication in between in your network lab, in that case it should use number of multiple one some of the multiple access protocols. So the first thing that you need to understand as far as multiple access protocols are concerned, that is, you have to ask the question to yourself that why these protocols have been used. And it is specifically given in a data link layer. That means if you see if you know the reason, if you know the purpose of data link layer, then you will understand, and by the time you will come to know how many protocols are there and how they have been used. So directly I'm going for the next slide. Is it okay with the first slide, students? Is it okay with the first slide? Yes, thank you. Let us go for the next slide. Yes, have you studied these protocols, all these protocols, students? Well, this is it's a tree you are watching there. Multiple access protocols, under which we have three categories of the protocols. The first one is a random access protocols. The second one is a controlled access protocol, and third one is a channelization protocols. We'll be going through all the protocols one by one today. Specifically, if you see the channelization protocols, they are very easy and very straightforward. So I have put it in a last no, as a last branch of this tree. We'll be starting with the random access protocol first, and then we'll go for controlled access protocols. But if you see the name of first two protocols, as the name indicates, the first protocol is a random access. I mean, there is no any mean for accessing the media. I mean, one can directly access the media without asking anybody. But as far as controlled access protocols are concerned, there is going to be a master. There will be someone who will be taking care of who will be accessing the protocols. And do remember one thing: whatever protocols we are going to discuss right now will be used for wireless communications. For example, see, everybody using a cellular system, cellular phone system, right? So there, these protocols will be used. If you have studied already, FDMA, TDMA. If you remember, few years before, there were some of the cell phones coming with the CDMA technology. You might have heard that no SIM card was there, GSM technology wasn't there, so CDMA was used there. So we'll be studying all these protocols one by one. If you want to note it down, you can have a note of it. As I said, if you have already covered these points, then you can consider it as a revision for your exam. So first protocol we'll be studying right now is random access protocols. So this is random access protocols. I'll give you some time, you go through the statements one by one. See, you have to ask the question to that point. I mean, why it is random access protocols? Why the name is random access protocols? So there is the very first point, as I've mentioned, there is no scheduled time for all the users. You consider some users in your network, 4 or 5 nodes in your network, which are capable, which are able to send and receive the signals. Let's say they have enabled with the wireless devices, so that they can send and receive the signals. So the very first point I have given, there is a no schedule time for any user, which makes it random access. As there is no schedule, as there is nobody to tell you can access the time, you can access the media right now, then you have to access, and then you. So there is no any kind of scheduling there. So it has been called as a random access. And because there is no scheduling, every user, every node, not user, but every node will be trying to access the medium at the same time. It can happen. So we can consider there is a competition in between the users. There is a competition among the users. So it is also been considered as contention methods. If you say this one, let me just use the highlighter. Do you see these words? Contention methods, students? Do you see these words? Yes, thank you. Please keep on saying yes, no, so that I can understand. Otherwise, I cannot understand anything from this point. So it has also been considered as a contention method. And see, the last statement is also very important. Each station has equal right to access the medium. So one cannot assign a priority there, that one cannot assign a weight there, that you have to access the medium right now and you cannot access the medium. So every node will be trying to access the medium at the same time. So it has been called as a random access protocols. Is it clear with you? Is it okay with you, students? Give me a big smile. Sorry, big like. Yes, yeah, yes. Thank you. Red T-shirt from JSUE. Thank you. Thank you. Thank you. Yes. Well, in this random access protocols, we'll be studying four protocols, out of which the very first one is a Aloha protocol. This is a Aloha protocol, and it was invented in 1979. You can understand how many years before it was invented, and we'll see how it has been used and how it works. So, and then we'll have carrier sense multiple access protocols with collision detection with collision avoidance. We'll be studying one by one in detail. So let us go for the first one. Have you seen this diagram before in your lecture room, classroom? Yes. It's a pure Aloha network. Under Aloha protocol, we have two more protocols. First one is a pure Aloha protocol, and the second one is a slotted Aloha protocol. You must have seen this diagram before. So let us go through the diagram. We have four stations. This is station 1, this is 2, this is 3, and this is 4. And if you see, this is your medium. This is your complete medium through which they will be sending and receiving the frames. And see, these protocols are working at data link layer. So we are dealing with the frames. This is frame. All these rectangle boxes are the frames. They are not the packets. They are not the TPDOs, that is from the transport protocol data unit, the data units. So as we are dealing with the data link layer, all these things you are watching there are the frames. They will be sending and receiving the frames. So let us consider this example to study pure Aloha network. Do you see this yellow colored highlighter and all, students? Is it visible properly? Thank you. Otherwise I will have to change the color. So see, we have something called as a collision duration here and here. We have two collision durations. Every station is sending at least 2 or 3 frames. If you consider this example, every station is sending only 2 frames. Frame 1.1 from station 1 and frame 1.2 is the second frame from the station 1 itself. Likewise, we have 2.1, 2.2, 3.1, 3.2, 4.1 and 4.2. See, as I said, every station will be trying to access the medium at random time. There is no any scheduling, and they will be competing with each other. There will be a competition for accessing the medium. Let's say station 1 has sent the first frame at this time. This is a random time. There is no any scheduling for that. So by this time, A has started, let's say 1 has started sending this frame, and after some time it has sent second frame. But if you see the timeline in between, station 2 has sent 2.1, that is its first frame. Station 3 has sent frame 3.1, that is its first, and station 4 has sent 4.1. Now if you see this medium, this particular diagram carefully, frame number 1.2, frame number 2.1, frame number 3.1 and frame number 4.1, they are there in the medium at the same time. So you can consider it as they are colliding with each other. So once any two frames collide with each other, you have to consider it has the frame has been destroyed or some signals have been disturbed. So you cannot consider these frames in between the transmission. So this particular area, which is given in a dark color, is called as a collision direction. It is called as a collision because there is no scheduling, because there is no any measure that who can send the frame at what time. The frames are going to collide with each other, and as we will be proceeding through number of protocols, you will come to know how they have tried to remove the collision or how they have tried to detect the collision. So at this point we have a collision among all these frames, frame number 1.2, 2.1, 3.1 and 4.1. Now the second example, if you consider this particular area of the diagram, frame number 2.1 and frame number 4.2, both the second frames from station 2 and 4, they are colliding somewhere here. So these frames will not reach to the destination successfully because there is a collision. Some of the signals, some of the bits from the frame should get disturbed, should get changed. Only 2 frames will reach the destination successfully without the collision, that is frame number 1.1 and frame number 3.2. See, right now on the right hand side, we might have some destinations, or you can consider some of the stations 1, 2, 3, 4 as a source and as a destination also. Let's say one is sending something to 2, one can send something to 3, or can send something to 4. So you don't need to worry about the right hand side of the diagram. It's just a timeline how the frames are traveling from getting transmitted from a number of stations to other stations. So this particular area is called as a collision. So according to the pure Aloha network, as we are studying the very first very first protocol from the random access protocols, the pure Aloha. In pure Aloha, there is no scheduling. Of course, as it is a part of random access, all the stations will be trying to send the frames at the same time or at any random time, at any interval of time. And because of which, there will be more possibility of getting the collision in between. So number of frames will get discarded or will get disturbed. So only 2 frames will reach to the destination as far as this example is concerned. So this is all about the pure Aloha network. See, and while comparing number of protocols, we have to consider their performance, the way they are sending the frames to each other, and the very important point that you need to consider is a vulnerable time that we'll be studying right now. Well, this is a procedure, this is a flow chart you can consider for pure Aloha network. Well, some of the key points that we need to consider right now as a K is a number of attempts you can consider. TP is a maximum propagation time. You will come to know what is the meaning of maximum propagation time in next few slides. Then we have TFR, the time taken by the frame. You can consider frame transmission time, and TB is a back off time. If one particular station sends the medium is busy, then you will have to wait there for some certain amount of time. That time is called as a back off time. It will wait there for some time. So if you go through this flow chart, this is very simple. Let's say one of the station has one frame to be sent, so it will start sending the frame. Because it is starting the frame for the first time, there is no any attempt, so K will be equals to 0 only. It will send the frame, and then it will wait there for some time to receive the acknowledgement, and it will be checking if the medium is busy or idle. So it is going to wait there. Now this 2 into TP is very important. TP, as I said, it stands for propagation time of the frame. I'll be explaining what is propagation time in the next few slides, and it is 2 into TP. For pure Aloha network, the vulnerable time is 2 into TP. I will explain that. So as far as this flowchart is concerned, it will wait here for the acknowledgement. If the station receives the acknowledgement, then it will be considered as a successful delivery of the frame. If no, then again it will go for the next attempt, that is K plus 1. And there is one consideration that the maximum value of the K should be 50, not more than that. If that for that particular station the value of K exceeds a 15 value, then the transmission will be aborted. Otherwise it will keep on transmitting the same frame. So here again it is going to check choose a random number R. See, if you go for if you consider this diagram, if station 1 sends one frame, first frame, then immediately it is not going to send the second frame. It will be sensing the medium. It will be waiting for the acknowledgement from the receiver side. If you are not receiving the acknowledgement from the receiver, then you will again send the same frame. This is how it works. And because there is a more possibility of collision in the pure Aloha network, it takes more time to send the frames. So this is the timeline. And if you are waiting for long time and still you are not getting the acknowledgement, then the transmission will get aborted. And this is the back off time. It will wait, it will come back, it will wait there for some time if the system is busy, if the medium is busy. So this is a flow chart. It's not that difficult. While explaining the thing in exam, you should draw this diagram, and if you remember the flow chart, then you go for the flow chart. And do remember these considerations, that K is number of attempts, TP stands for maximum propagation time, TFR stands for the time taken by the frame. It's a frame transmission time you can consider, and TB is a as a back of time. This is very important point. Vulnerable time for the pure Aloha network. By the way, are you people with me? Students, are you with me? Yes. Is it getting bored? Is it getting bored? Okay, thank you. Please keep on that. Otherwise, I'll try the way I'm delivering the lecture right now. Well, this is a vulnerable time point we'll be studying right now. Let's say uh, this is the first frame sent by B. This B stands for it is sent by B. This is one more frame A, and there is one more C. Let's say there are three frames in the medium, and because, as I said, every station is going to send the frame at some random interval of time. They don't know if say A doesn't know that B and C are sending some frames. B doesn't know A and C if they are sending the frames, and C also doesn't know, unaware of A and B if they are sending the frames. So there will be collision. Now we are talking about the vulnerable time. Vulnerable time is a time during which there will be collision in the medium. So you have to consider the vulnerable time like how long the collision is there in the medium, and longer the collision will be there, you cannot send the frame. You can send the frame, but there will be a collision throughout. So you will have to wait there. Now what is that time? That time is considered as a vulnerable time. You can see that, and we have to calculate the vulnerable time for the pure Aloha protocol. So if you are considering the timeline according to that timeline, then the C must have sent the frame for the first time. So C is on the right hand side. Then after that A has sent the frame. So it is in between B and B and C, sorry. And then B has sent the frame. If you see, A and B frames are colliding somewhere here, and frame A and C are colliding somewhere here. Now we have to calculate the vulnerable time. According to the diagram, you can see that this is a vulnerable time, because this is where the frame A gets collided with C. Agree with me, students? Are you agree with me? Thank you. And if you consider the B and A frame, this is where these two frames are getting collided. So while calculating the vulnerable time, you have to start from the beginning of the time where they have started sending the frames. So this is the vertical line. From this line, you have to consider the last collision point, that is the collision in between A and C. So this complete time is considered as a vulnerable time. Now in we can say in TP, that is total propagation time. TP stands for the propagation time of the frame. If we have to calculate in that TP, then it will be 2 into TP. Why 2? Because see, this is 1 TP. This particular time is 1 TP, propagation time for the one frame, and this is another TP, that is from this line to this line. This is, so it becomes 2 TP. See, the meaning is they are not sending the frames at the same time. They are sending the frames at some random interval of time. So if this is the first frame going through the transmission, and if the second frame comes in somewhere here, so you have to consider the starting point of the frame till the end of the collision. So it will be at least 2 TP or more than that. So the vulnerable time, which should not be there in the medium, see, listen to me very carefully. This statement is very important. The vulnerable time should not be there in the medium, because longer the vulnerable time is there, there will be a collision. See, while having this collision, if other stations start sending some frames, there will be again collision. So vulnerable time will keep on increasing. So the vulnerable time for pure Aloha network is 2 into TP, frame transmission time. Of course, it's a TP propagation time. You will get to know the difference between propagation time and the frame transmission time. For some of the protocols to be work in this wireless media, the frame transmission time should be more. That is, the length of the frame needs to be more than TP, propagation time. You will come to know. So the vulnerable time for the pure Aloha is 2 into TFR. TFR, as I said, is a frame transmission time, and TP is a total propagation time. If you people are okay with this, should I go for the next protocol? Is it okay, JSCOE and ICORE? Uh, okay, thank you. The next topic in next protocol in Aloha itself is a slotted Aloha protocol. See, keep the working principle of pure Aloha in somewhere in your main memory in your RAM, because we are gonna need that while studying this protocol. Same thing is there. We have the same graph. We have 4 stations there, 1, 2, 3, 4, and they will be sending the frames. Again, they are sending the same number of frames. Yes, 2, 2, 2. They are sending the frames. But there is a difference in between pure Aloha and this slotted Aloha. In slotted Aloha protocol, there are number of slots given for every user. Instead of saying every user, you will consider we can consider as a number of slots. But the thing is, if any station wants to send some data to another station, wants to send some frame, that station needs to start by the beginning of the timeline. So if you consider this particular timeline, this is the very first time slot. You can see there we have number of slots. This is slot 1, this is slot 2, 3, 4, and etc. Station 1 is having some data, and by slot 1 it has started sending the frame. But the point to be considered, the point which is important from this diagram is it has started sending the frame at the beginning of the timeline. To remember this statement, every station can send the data at any time. Any time means in any slot, but the thing is they have to start sending the frame at the beginning of the time slot, not after the time slot. If you consider the station 2, let's say station 2 is having one more frame, and if it starts sending the frame at this time after beginning of the time slot, do you see the gap in between the line and the frame, students? Do you see the gap? Yes. Okay. Thank you. Thank you. Thank you. So none of the station can start sending the frame like this, as the station 2 has started for this example only. So they have to start by the beginning of the timeline. See, like this only. So if you observe the diagram very carefully, every frame you can see that every station has started sending the frame at the beginning of the timeline. The meaning of at the beginning of timeline means that the time slot is these vertical lines are the time slots. See, these are the time slots. So every frame should start by the timeline only. If you consider this one, say it is starting with the beginning of the timeline. Again this one, this one, this one, all the frames. Now how this particular slotted Aloha protocol is helping to minimize the vulnerable time, I'll tell you that. See, station 1 has started sending the frame 1. It has sent the frame. But if you see station 2, station 3 and station 4, they don't have any frame in the same time slot. So there will not be any collision. So frame 1 will definitely reach to the destination. The same thing is here for frame number 3.2, frame number 4.2 and frame number 2.2. But there is a collision at this point. I mean in this time slot 2 and time slot 3. Why collision? Because there are 2 frames parallelly present in the medium. That is for the sure, of course. But how is it different from the pure Aloha network? How the time slots, how the slotted area is helping this particular protocol to minimize the vulnerable time? That is very important. If you see, as I said, every station will be sending the frames at the beginning of the time slot. So station 2 and station 3 has started sending this frame and this frame at the same time. So there will not be this kind of situation, like if this is the first frame coming and if this is the second frame. In pure Aloha network it was like this, but in slotted Aloha network it will be like this, if you consider these both things as frames, because of which the total vulnerable time will get reduced. If you remember the previous diagram, number of frames are colliding each other. Actually there are 3 frames coming from A, B and C, but if you see the distance, they are starting somewhere here and the collision is there till this line. So this is a vulnerable time. But in this diagram, if you see, as the frame is starting somewhere here at the beginning of the time slot, and from station 3 also at the beginning of the time slot, So they are not going beyond the one time slot. So the maximum time the collision will be there is equal to the one time slot. Well, there is one more point to be considered for this protocol to work successfully. The length of all the frames sent by all the stations should be equal. That is very important. If the length of the frame sent by A is this, do you see this frame? Can you see this frame? Students, is it okay? Students sitting on the first row. Yes, thank you. This is, let's consider this is one frame and this is another frame. You can, oh sorry, you can see the difference between two frames. The length of the first frame is more and the length of second frame is less. So we cannot have these variable length frames in your slotted Aloha network, sorted Aloha protocol. So the length of the frame needs to be equal. So then and then only they will end by before the beginning of the next time slot. So the vulnerable time in this case for this time slot is equal to FRF, TFR, that is frame transmission time, that is TP, total propagation time. This is another collision point where we have frame from station 1, that is 1.2, and frame from station 4, that is 4.1. They are getting collided here. Yes, this is a vulnerable time what I was talking about. Let's say B has sent the frame, but there is no more frame present along with B, so there is no collision, of course. But if you see this particular area, there is a collision, of course, because A has sent one frame, C has also sent one frame, but they are A and C has started sending. They have sent the frame at the beginning of the time slot only. This is what I'm talking about, at the beginning of the time slot. So they will not we can say they cannot travel through another time slot. They cannot reach to another time slot. They will be strict to one time slot only. So vulnerable time will get reduced. Just hold on for a moment. I think there is a problem with the system. Just give me one moment, students. Is it okay? Thank you. Thank you. Yes. So if you see, the length of the frame is equal and they are in that same time slot. So the total vulnerable time is equal to TFR. And in previous protocol, in pure Aloha protocol, it was 2 into TFR. So this is the difference. Of course, as the diagram and if you consider the vulnerable time, the slotted Aloha network is more efficient than the pure Aloha network. So this is a part of Aloha protocol. From random access protocols, we have, and I'll consider it as a done Aloha protocol, in which we have two protocols. First one is a pure Aloha protocol, and the second one is a slotted Aloha protocol. This is the diagram for that. You just have to draw a number of slots there, but the length of the slot and the length of the frame should be equal. This is the point to be mentioned. Should I go for the next protocol, student? Should I go for the next one? Yes. Are you really understanding what I'm saying? Is it okay with the speed? Hello, is it okay with the speed? Okay, girls sitting on the first row, they are not answering anything. NTC, which is this campus? I don't know NTC. Okay, we'll go for the next protocol now. Next protocol is carrier sense multiple access protocol. This protocol is also very easy. I'll give you some time to go through the diagram. Let us go through the diagram. We have 4 stations: station A, station B, station C, and station D. It's not a physical topology there, it's a timeline. The vertical line indicates a timeline. This particular line, yes, this is a vertical line and it's a timeline. It's not a physical topology. Don't get confused. I have seen number of students they got confused. They are considering like it's a physical topology. A is connected to B, B is connected to C, and C is connected to D. No, there is a wireless communication among these stations, and this is just a timeline when every station will be starting sending the frames. This is what we have to understand from this particular diagram. For this protocol to be work successfully, there is a principle, and that principle I have written on this slide. Sense before transmit. Before you start saying something, you have to sense the medium. I used to give the example, and I'll give the same example. If you're sitting in a classroom and if your faculty, if your teacher is saying something, and let's say you have a doubt, in that case, you just cannot stand up and you just cannot ask your question to your faculty. You will wait there until your faculty, until your teacher finishes whatever he is saying, whatever he is delivering, and then you will raise your hand, and then you will ask for the permission. And if teacher is giving you the permission, and then you will start asking your question. Now, raising the hand means you are trying to access the medium. But before raising the hand, you were just sitting there and you were listening to the faculty. Though you have a doubt, though you have a question, you weren't asking the question. You were waiting there for the teacher, for your faculty to wait. That means you are trying to sense the medium. Otherwise, there would have been a collision. The same thing is applicable here as far as this carrier sense multiple access protocol is concerned. Before you start sending the frame, you have to sense the media. So listen before talk. That is sense before transmitting. Now in this diagram, well, let me change the color. Where can I change color? Option. How can I change the color? Just give me a moment, because you won't be able to see the changes which I'm gonna make there. Will I? Yes, in color. I'll make it red. Now it is okay. Yes. Yes. A, B, C, and D we have. Let's say B is going to start sending the frame at time T1. B is sending the frame right now. Now, if you see this particular area, see this is the point where B has started sending the frame. This is T1. As I said, these vertical lines are the timelines. Now, this particular area is the area covered by that frame. See, this is the line. You can consider this as a frame. This is the way that the frame is moving. The frame will be traveling through the medium. On left hand side we have station A. On right hand side we have station C and station D. So this is how the frame will be moving. But in between, because C wasn't aware that B is sending the frame, by time T2 C has started sending the frame at this time. This is time T2. And see, if you see this particular point, do you see this point, students? Do you see this point? Okay, some of the students are sleeping, I think. Don't sleep in between the lecture. It will take only 1 hour. I'll complete all the protocols and then you go for your no, you have already taken your lunch, right? Have you taken your lunch? Hello? Say yes, sir. I haven't taken my lunch still. This is one point. What is this point, students? See, the frame sent by B is traveling like this, and the frame sent by C is it has started sending the frame at time T2, and they are going to meet here at this point. So what this point is? What is this point, students? Can I consider it as a collision point? Hello, NTC, JSCOE, ICOR. Is it a collision point? Say yes. Yes, thank you. It's a collision point. This is a collision point. But see, joke apart, but none of the station is aware of this collision. Neither B nor C, they are not aware of the collision. At this particular time, C will receive the first bit sent by station B. And if you see this particular time, this one on the left side, just below B, B will receive the first bit sent by C. See, it will be like this. And then B will receive the first bit sent by the C. So at this time, B will come to know C has already sent the frame and I should stop sending the frame. And at this point, C will come to know that B has already sent the frame and I should stop sending the frame. But see, we don't have right now anything to stop the collision. We don't have anything to remove the collision properly, to prevent the collision completely from this particular medium. But what we have to understand from this particular diagram is the way all the frames will be traveling through the medium. If B is sending the frame, then it will be like this. You can see from the diagram. You can see in the diagram. If C is sending the frame, it will be like that. So this particular area, this is the area where signal coming from both the stations will be there. The signal coming from B and the signal coming from C will be there in the transmission media. So this is that area. If you see this yellow color region, this is a region for A station. You can consider the signal coming from the A, and this blue colored area is area where you can say the frame sent by the C is present. So this is how it is. I know I have drawn number of lines on in that diagram, but I hope you people can understand that. This is the diagram. So what you have to understand from this diagram is there are four stations A, B, C, D, and as far as carrier sense multiple access protocol is concerned, it works with the principle of listen before you talk, that is sense before you start sending the frame. Because let's say by T1 time B started sending the frame and B sent the frame, it is continuously sending the frame. At time T2 somewhere, because C wasn't aware that B has started sending the frame, C started sending its own frame. So somewhere both the frames are going to collide each other. Let's say this is the frame coming from B and this is the frame coming from C. So somewhere like this they will get collided, and there will be a region in the medium, there will be area where the signal coming from the both the stations will be there, and that is what we have to avoid. That is a collision. We are not expecting any kind of collision in between the transmission. Otherwise you will have to send the frame, that is all the stations will have to send the frames again and again until you receive the acknowledgement. So for this carrier sense multiple access, you have to understand this particular diagram. Uh, just let me. Okay. Yes, now it is okay. Now we have to again consider the vulnerable time for the sorry, multiple access protocol. Sorry for that. Again, we have the same example. We have four stations: station A, B, C, and D. Now you will come to know what is a propagation time, total propagation time for the frame. See, of course there is a wireless communication among these stations. This is station A. For station A, B is little closer as compared to C and D. C is more closer than D, and D is far away from station A. So if you consider this distance, this is the maximum distance we have in this network in between A and D. Do you agree with me, students? Do you agree with me? Well, some of the students are really not listening to me and they are not watching the slide. Please pay the attention, because once you understand these protocols, you don't need to revise it again. You can directly go for your examination and see while studying the next units of the CFCA. You should know all the protocols, how they work, because you will be working, you will be studying how to investigate, how the crime has been occurred. So you should know the background of the network if you're being a forensics and cyber application or the crime investigator while studying these points. So do you agree with this point? This is the maximum distance we have in between these two stations, station A and station D. Now what is propagation time? Propagation time, maximum propagation time is the time taken by the frame if it is starting with station A to reach to station D, because the maximum distance among the stations is in between station A and station D. You can watch this from the diagram. So this is the distance I am talking about. So the propagation time is, if by time T1, do you see time T1, students? First row students? Yes, thank you. Yeah. By T1, A is started sending the frame, and this is how the frame is, frame is proceeding, frame is traveling through the medium. You can see that this is how it is traveling. At certain time, let's consider this as some time. I'll write there T5 or T6 something. Let's say T2. At this point, B will receive the very first bit sent by A. Listen to me very carefully. At this point, B will receive the very first bit of the frame sent by A, and that is where B will come to know A has started sending the frame and I should not be sending the frame. If you say this, Just give me a moment. What is the problem? काय problem आहे काय? Okay, okay, fine. Just let us give him a moment because parallelly some other work is also going on and yes, thank you. Let us continue. Where is my pointer? I lost. Yes. This is the point. This is the time where B will receive the first bit sent by A and B will come to know as A has started sending the frame, I should not be sending the frame. Otherwise, there will be definitely a collision in the medium. So before this time, you can, if you see, before this time, yes, before this timeline, above that timeline, A, B, C, D, all the stations were sensing the medium and the medium was idle. If you see in this particular timeline, in this time, none of the station is sending anything. So the medium is idle. So randomly by time t1, A started sending the frame. At this particular point, B received the first bit sent by the A, and B come to know that A has started sending the frame. B will not be sending the frame. At point this, let's say this is a t3 time, C will come to know that A has started sending the frame because C is going to receive the very first bit sent by A. Listen to me carefully. At this point, C will receive the first bit of the frame sent by A and C will come to know there has been a frame sent by A. So C will not again transmit the frame. Otherwise, there will be collision. C knows that. Now for D to receive that frame, it is going to take this time somewhere and D will receive the first bit sent by the A. So if you see this particular bracket, this particular time is a vulnerable time. This is a propagation time, and as I said, the propagation time is the time or the difference between, see, this is going to be your propagation time. Let me draw a line for you. This is a horizontal line, and this particular time, the difference between these two times is a propagation time. This is the time, this is the maximum time will be taken by the frame to start from station A and to reach to the station D, provided that station A and D are away from each other as compared to far away from each other, or they are at the maximum distance as compared to other two stations, other 3 or 4 stations. So this is a propagation time. If this is station A and this is station B, the time taken to travel by the frame from station A to B, A to D is considered as a total propagation time. And the vulnerable time for this carrier sense multiple access protocol is this, because the moment A started sending the frame and the time at which D has received the frame, before that time D wasn't aware that A has started sending the frame. So in between that time, in between somewhere here, D could have started sending the frame, and that would have been a collision in the medium. See, in this particular time slot, C is still sensing the medium as idle. So C could have started sending the frame again. So that's why this particular time slot is called as a vulnerable time. And for carrier sense multiple access, the vulnerable time is this. You can consider it as a TP. So what one particular station should do after sensing the medium as a busy, what it should do if the medium is busy, if the medium is idle, whether to wait, whether to start sending the frame. To answer these questions, they have come up with, under the carrier sense multiple access protocols, with 3 persistence techniques, 3 persistence methods. You can see that the first one is I persistence. Is it visible to you, students? Hello? Is it getting bored? Is it getting bored? If it is okay, please then raise your both hands, please, for me. Yes, you can raise that. Yes, thank you. There are 3 persistent methods. The first one is I persistence, one persistence. Then second one is non-persistence, and another one is periodically, that is P persistence, probability persistence. We'll discuss the very first persistence point first. See, we have discussed this diagram, we have studied this diagram, we have studied how the carrier sense multiple access protocol is going to work. See, this is the timeline only. this is the diagram for that. Now we have to study what a station should do after sensing the medium as idle. What the station should do after sensing the medium as a busy. So if you see in the first type, I persistence, these vertical lines, these vertical arrows indicates that you consider yourself as a station and you are sensing the medium. The vertical arrow indicates you are sensing the medium, and this particular box, yes, this particular box indicates the medium is busy. That means some other station, one other station is sending the frame. So the medium is busy. So you cannot send the frame at the same time. Now, sensing the medium busy means receiving the first bit of the frame. If you consider B, if you consider C, the receiving the first bit sent by A. So from here onwards, you will be sensing the medium as a busy. So these vertical arrows indicates that you are trying to sense the medium. You are you have some data to be sent, and you are sensing the medium. And because somebody else is sending the data, you're sensing the medium as a busy. You are not able to send the frame. You will not be sending the frame. After some time, let's say there is one more arrow, this arrow, and you sense the medium as idle because there is no frame. The medium is not busy. You see that after end of this particular frame, this particular rectangle, there is no any box. So medium is idle right now. So according to I persistent techniques, once any station finds that particular medium as idle, can start sending the frames immediately. So that I you can consider as a immediately, as a immediate. So after sensing the medium idle, station will not wait there for a moment. It will automatically, it will start sending the frame at that point only. So this is what I persistent. See, we are talking about two questions. We have to find the answer for the two questions. The first question is what a station should do after sensing the medium as idle, and the second question is what a station should do after sensing the medium as a busy. So as it was busy, you have to wait there. You cannot send a frame. The moment you come to know, the station comes to know that medium is idle, you immediately start sending the frame. So this is first persistent, that is one I persistent. This is the first part out of the three persistent technique. The second is a non-persistence. See, the same thing is same thing is there. Being a station, you are sensing the medium. Once you sense it and once you find that medium is busy, it is busy. See, this is busy right now. You will wait there for some time. You will not be continuously sensing the medium. Because you have found out that medium is busy, you will wait there. You will not be sensing, you will wait there for some time, some random amount of time. After again some time, you will again sense the media. Again, if you find it busy, you will again wait for some time. And again, let's see, there is a third arrow. You are sensing the medium and you have found that medium is idle right now because there is no transmission, because there is no any rectangular box. So there is no transmission. You have sensed the medium as idle. You will wait for some time and you will start sending the frame. The difference between I persistence method and the non-persistence method is, in I persistence, the station was continuously sensing the media, and once it find out that medium is idle, it will immediately start sending the frame. And in non-persistence method, if you see in the diagram, it will wait for some random amount of time. Though the medium is not busy, the medium is idle, it will wait for some time and then it will start sending the frame. Because it can also be possible that as we are considering only one station there can be one more station who is parallelly sensing the medium, and let's say it is also sensing the medium as busy. So at the same time, station A and station B can sense the media as idle. So both the stations can start sending the frames at the same point. So there will be again collision according to the I persistence method, the first persistence method. So in non-persistence method, though both the stations are sensing the medium, let's say this is A and this is B, they both are sensing the medium. If A find out medium is idle right now, A will not start sending the frame. If B find out the medium is idle, again B will not start sending the frame at the same time. They will wait for some random interval of time, and they are totally unaware of each other. That A is sensing the medium, B is sensing the medium, and they each have some data to be sent, some frames to be sent. So they will wait for some random interval of time, and then they will start. So this is the difference in between uh, I persistence and non-persistence. Have you understand by these two diagrams and the difference between two methods? Understand? Is it okay with the speed, students? NTC, I-core? Yes, thank you. Thank you very much. Some of the students are doing like this, so maybe they, they want me to stop, I think. Are you getting bored? Are you getting bored there? Students, red color t-shirt from JSCOE. Hello. Red t-shirt, yes. He's really enjoying my lecture. I like the way he's, yes, thank you. Thank you for that. Yes. See, we should not get bored. I'm trying to make it more interesting for you people. We are left with very, very few protocols only, and after some time we'll definitely stop. Let me go for the third one. Yes, it's not visible right now. Let me, for me it is not visible. Yes, for you people it is okay. Yes. The third one is a P persistence. In P persistence method, P stands for the probability. You just have to understand one thing. Every station will be calculating the probability after sensing the medium, and it will wait for some time, and then it will start sending the frame. See, it is continuously sensing the medium. The first point similar with the first persistence method, I persistence method. They are sensing the medium. I mean the station is sensing the medium. It is busy. Once the medium gets idle, no transmission of the frame is there. This is idle. It will wait for some time slot. After waiting for some time slot, that particular station will select a probability P and will start sending the frame. It will send the frame. Once you find out the medium is as idle, it will select one probability and it will start sending the frame. The second point is, once you complete with your transmission of the frame, while going for the transmitting of the second frame, it will calculate the probability Q. And what is Q? Q is equal to 1 minus P. See, Q is equal to 1 minus P. The P probability is the probability at which the station A had sent the frame. Then, of course, 1 minus P should be there. It will calculate Q, and it will wait for Q time. It will wait there for the Q time until the beginning of the next time slots. So if you see these vertical lines, these are the time slots you can consider, and this Q will be the waiting time for that particular station. So the very first thing that you need to understand by this P probability persistence is, it will change the media continuously. After sensing the medium as a idle, it will select one probability, I mean probability P. You can see on your screen, this is probability P. It will start sending the frame. Once you finish with the sending of the frame, you will calculate Q, that is remaining probability, that is 1 minus P. It will be in a point somewhere. It will wait for Q probability for the beginning of the next time slot. Because if you remember the slotted Aloha network, in which we had number of time slots and every station was sending the frame at the beginning of the time slot. The same thing is applicable here. Every station will start sending the frame at the beginning of the time slot. So to remove the gap in between the beginning of the time slot and end of the previous frame, they are waiting for that particular time, and that time is called as a Q, that is probability 1 minus P. This is the flow chart for 3 persistence methods. They're very, very simple and very straightforward. If you see in I persistence, it is continuously checking. If the medium is busy, then again check until you find it is idle. You cannot start sending the frame. Once you find it is idle, you start sending the frame. See, it is waiting randomly here in non-persistence method. Once you find it is busy, you wait for some time, then go for sensing the media. Again, if you find it busy, wait for some time. So you don't need to continuously sense the media. You have to wait there for some time. And in the third one, you have to check the outcome of the probability every time, if it is less or if it is greater than the P. If it is greater than P, you will have to wait for some time slot, and then again change the medium. Once you find the medium idle, you start sending the frame. So this is how carrier sense multiple access protocol work as far as these three persistent methods are concerned. I was talking about what a station should do. There were two questions. Do remember these two questions. What a station should do after sensing the medium as a busy and after sensing the medium as a idle. So this is what they are going to do according to these three persistent methods. Let us go for the next protocol. Should I continue with the next protocol, students? Should I continue? Yes, thank you. Thank you. This is carrier sense multiple access with collision detection. Have you studied this protocol in a classroom? Have you studied this protocol? Not studied? Okay, then then you have to listen to me very carefully. These protocols are very important. If you are not studied, then of course I thought that faculties have already completed this protocol. So let us go for this. The same thing is there, carrier sense multiple access, but /CD. CD stands for collision detection. See, we have two more protocols. The first one is collision detection and one is a collision avoidance. Collision detection means, of course, there is going to be a collision. You just have to detect the collision. And what should be the purpose of detecting the collision? See, the purpose behind that is, once you come to know, let's say you are a station A, B and C and D. Once you come to know there is a collision, you should stop sending your frame. I will explain that thing with this example. Do you see this diagram with? Do you see this diagram, students? You don't see the diagram? Is it visible? Okay, thank you. I request the concerned faculty member just to take care of the diagram. I mean, take care of the if students are really, if they are able to see the diagram. Is it properly visible to you, students? No. Okay. Let me check what's wrong with the diagram. Sir, excuse me. Sir, डायग्राम दिसत नाही आहे कदाचित पलीकडे. Is it visible now? Is it okay? Thank you. Thank you very much. Yes. With collision detection, see, the purpose behind this protocol is to, once you detect the collision, you have to stop sending the frame. But see, the point to be considered here, the point which is important from this protocol's point of view is, one should come to know that there has been a collision. That is important. See, there is station A, station B, station C and D. We have 4 stations. Just let's go through the diagram. At time T1, A has started sending the frame, and this line indicates that this is how the frame will be traveling through the medium. This is how it is sending. Let's draw a timeline for node B also, station B. This is the time where B will receive the very first bit sent by A. Do you agree with me, students? Do you agree with me? Bachate sir? Thank you. At this point, B will receive the very first bit sent by A. So B will come to know A has already started sending the frame and I should not send the frame. This is what B will come to know. But as at T1, A has started sending the frame, and see, until the frame sent by A reach to C, before this T3, there is T3, there is T2. After T1, after this T1, by T2, because C was sensing the medium and the medium was idle for C, for D, C started sending the frame at time T2, at time random time T2. See, this is where C has started sending the frame. So the same thing is there. So this is the frame coming from the A, and this is a frame coming from the B, and this is where somewhere they are going to collide. See, and this is the collision points. Do you see the collision point, students? Do you see the collision point? Yes, thank you. This is a collision point. This is where both the frames coming from the stations are going to collide, and once they collide, of course we are not expecting any kind of collision in between the transmission, but we have to find out when C is going to when C will come to know that there is been collision, and when E will come to know there is a collision. So to answer for these questions is either of the node, I mean C should receive the frame sent by A, and A should receive the frame sent by C. See, this is the point where C will receive the very first bit sent by station A, the very first bit of the frame sent by station A. So at this time, and this time is nothing but time T3 in the timeline. By T3, C will come to know A has already sent the frame, and I had started sending the frame by time T2, so I should stop sending the frame. So C will stop sending the frame, but still C has, though C has stopped sending the frame, some of the signals will be there in the transmission, and after some time they will reach to station A by time T4. They have considered this time as a T4. So if you see the total time taken by the frame to reach to station D and station A is this time. This is a transmission time, and I was talking about detection of the collision. See, this thing is very important. Listen to me very carefully. One station will come to know that there has been a collision until and unless that station receives the signal coming from any other station. Otherwise, the station will not be able to to detect any kind of collision there. So for this protocol to work successfully, it is very important the length of the frame. See, this is how the frame will be traveling. This is the red line I am talking about. This is how the frame will be traveling, and still it is traveling, and then it will reach station D. So for station D to know that A has sent the frame, station D should receive the very first bit sent by frame A. Agree with me, students? Yes, thank you. Because station D should receive the very first bit sent by A. Until D receives anything, there is no way that D will come to know that A has started sending the frame. So for D, the medium is totally idle. So D could have started sending the frame in between somewhere before, you can say before, what is that time? Before T3. Before T3, it could have started sending the frame, but it has not started sending the frame. So for this protocol to work properly, the important thing is the length of the frame should be more than TP. TP stands for the total propagation time. Total propagation time means okay, this is the first time slot, and this is another time slot. And if the frame is starting at this point, so frame should be continuously there in a transmission like this. So it should be like this. So this is your complete frame, and of course there is some part of the frame with station A. I'm considering this as a station A, and this as a station D. So the frame should be there in a transmission continuously. Then and then only D will come to know there has been a signal coming from the A, and then D will not start sending the frame. They will not send the frame. I don't know what is wrong with the system. Yeah. Okay. So for this protocol to work properly, see, A had sent the frame. It is getting collided with the frame sent by C. At this point, C has sent the frame, and by T4, A is going to receive the receive the first bit sent by C. Until A receives, this is A, until A receives the signal coming from C, there is no other way that A will come to know that C has started sending the frame. So the length of the frame should be more than 2p or TP for station D, if you consider. This is how collision detection protocol works as far as carrier sense multiple access protocol is concerned. See, this is one more timeline. This is where they are getting collided. See, you can see this yellow part is a part of frame sent by C, and this blue part is a part of frame sent by A. This is how, see, they are going to collide in this timeline. This is time T1, this is time T4, this is T2, and this is T3. So this is how carrier sense multiple access collision detection protocol works. This is the flow diagram for that flow chart. I will not be going through this flow chart because this is very easy. You can study this protocol after by using some books also. You will find all the stuffs in a book also. Well, they have mentioned one more point as far as energy level of the signal is concerned, energy of the medium is concerned. If there is a frame under transmission through the medium, then the energy of the medium will be like this. The medium will be this. If there is no transmission, if it is idle, the energy will be zero, no energy. And if two signals are getting collided, the energy level will get increased. This red color indicates that there is a collision and the energy level will get increased. So idleness and the collision, this is the energy level during the transmission for that medium. Just to consider the point. Let us go for the next protocol, that is carrier sense multiple access with collision avoidance. But I mean, are you clear with this protocol, students? Carrier sense multiple access with collision detection. Students, can I have some answers? Can I have yes, no? Have you really understand by this protocol? Let me repeat this protocol once again so that you will understand. This is carrier sense multiple access protocol with collision detection. As I said, to detect the collision, see, to detect a collision, because see, none of the station is connected to each other directly. There is a wireless communication. Any station can start sending the frame at any interval of time. So by T1 in this diagram, A has started sending the frame, A is sending the frame. Until C or D receives the signal coming from the A, B, C and D are considering the medium as idle because they don't know whether A has sending the frame or any other station is sending the frame. This is the first point. Because of which at time T2, C has started sending the frame. So now there are two frames in the medium parallelly traveling in both the directions, in this direction and again coming back that direction. So they are getting collided somewhere close to station C. So this is where they are getting collided. Now collision has occurred, but we have to detect the collision. We means these four stations have to detect the collisions. But how they will come to know that there has been a collision? Now you have to ask two questions. How many nodes are sending the frames? There are two stations who are sending the frames, station A and station C. It's okay with station B and D. A should come to know that C is sending something data to some frame, and C should also come to know that A is also sending the frames. Then and then only both the stations will come to know there are more frames present in the transmission media, and definitely there is going to be a collision. We should stop sending the frame. And just to know this thing, A on the right hand side should receive the signal coming from the C, and C on the left hand side should receive the frame coming from the A, that is signal coming from the A. So I mean, if you are saying that the signal should reach to the C, should reach to the D, there should be a continuous signal in through the transmission. I mean, the length of the frame should be more than the total propagation time. That is expected for this protocol to work successfully. So this is a core part of this carrier sense multiple access with collision detection technique. I can understand it's difficult to from my side and for you also to just to listen to me only once and to understand the protocol. But this is how it is. At least I can consider it as a introduction of these protocols. So once you get some time, you can study these protocols in detail after some time. Let us go with the carrier sense multiple access with collision avoidance. CA stands for collision avoidance. We have to avoid the collision. See, whatever protocols we have studied till now, uh, we tried to remove the collision, but it wasn't working there. We cannot remove the collisions completely. All the way, all you can do, or all these protocols can do there, I mean, they were only detecting the protocols, and if there is a collision, then they will again send the frame. That is the only thing they were doing. In this protocol, we'll try to avoid the collision. How it can avoid the collision? This is the way. In carrier sense multiple access with collision avoidance, the very first point is IFS. This IFS stands for, do you see that IFS in the diagram? Do you see the IFS, students? Do you see that? Just give me a like. Yes, yes, thank you. IFS stands for interframe space. Interframe space means yes, if this is one frame and this is another frame, then you don't need to consider the frames at every time, but for to make you understand, you consider two frames. So there will be a space in between the frames before sending 1, 2 or 3 or more frames. You just cannot keep on sending the frames. You will have to wait in between while sending the frames. So IFS stands for interframe space. And then we have something called as a contention window. Contention window is a time that every station will be waiting before it can send the frame. I will explain the thing in a detail. Just करा ना ते. सर कुठे गेलेत ते? त्यांना तर बोलवून घ्या, तेजस सरांना. हे असं फार प्रॉब्लेम देते, मग माझं फार वेळ लागेल ना पॉइंट्स कंप्लीट करायला, अजून खूप पॉइंट्स आहेत. येस, we'll go through the diagram and then you will come to know how carrier sense multiple access with collision avoidance works. See, the first point is, being a station, you will be continuously sensing the medium. These vertical arrows indicates that you are sensing the medium. Now, right now, somebody is sending the frame, somebody is sending some data, so the medium is busy right now, so you cannot send the frame. After some time, you sense the medium as a idle. See, this is the arrow, this is the last vertical arrow where one particular station will has found that the medium is idle. So according to I persistency, if you remember, it was started sending the frames immediately, but right now it is not sending the frame immediately. It is waiting there, and that waiting time is called as a interframe space. It is waiting for some time. After waiting there for some time, that station will select any random number from R. Let's consider it as a R. From R, it will consider small r, any random number, and that random number will be in a exponential, in a binary exponential format. I'll tell you what the meaning is. Right now, let us find out how many slots are there. There is 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 time slots. So that particular station must have selected number 9 randomly. See, it was sensing the medium continuously. The medium was busy, so it wasn't sending the frame. Once that station find out that station is not busy right now, it is idle, it is waiting for some IFS time, interframe space time. After waiting for that time, again it is not sending the frame. It has selected one contention window, and that window size will be R. For this diagram, the window size is 9. It is 9. So it will be waiting for 9 time slots, vertical time slots. It is waiting there for 9 time slots, and after waiting for 9 time slots, still the medium is idle, then that station can send the frame. This particular rectangle indicates that it has sent the frame. So this is how it works. So in carrier sense multiple access with collision avoidance, there are 3 points which are very important. The first point is interframe space. It is a time, it is a space in between 2 frames before you can send the frames. There has to be a duration of this much. This is interframe space time. The second thing is contention window. Contention window is a number of time slots. Contention window will be a time slots, number of time slots, that every station is going to select one random number. In our example, the random number is 9, and it will be waiting there for 9 time slots. So once it waits for those time slots, then you can actually send the frame. One more point in this, let's say you have waited for first time slots, just observe the diagram properly. You have waited for second time slot, third and fourth. You have completed fourth time slots successfully. That means until waiting for 4 time slots, the medium is still idle, not busy. But after completing the fourth, as you are proceeding for the fifth time slot, let's say somebody else has started sending the frame, then medium will be busy. There will be one more box here and will be written busy there. Now in that case, you cannot keep on going through the time slots. You cannot complete your contention window. You will have to wait there. That station will stop the counter and will wait there, and again it will start sensing the medium. The very first thing, continuously sensing. Again it will continuously sense. Once you find it idle, it will go for interface time, interframe space time, and then it will continue with the same contention window where it has left. We had completed 4 time slots, then it will start with the next time slots in the next time. So this is how it works. See, because of the interframe space time and because of this contention window, both the things are there for the waiting time as a waiting time. And see, every station is going to select any random number this from this R. So it will not be possible that it will not happen that 2 stations are going to select the same random interval of time. They will be selecting different different interval of time. So because of this contention window, we can avoid the collisions successfully. So the last protocol from random access protocol is carrier sense multiple access with collision avoidance. This protocol is little bit complex to be implemented, but to understand it is very easy. There are 3 parts in this protocol. As I said, the first one is an interframe space, the second one is a contention window, and the third one is a acknowledgement. Even after having all these precautions, if there is going to be a collision still, then that station, it will be waiting for the acknowledgement. If you don't receive the acknowledgement from the receiver, then again you will start sending the same frame to the receiver. So this is how this protocol works. I can understand you are continuously listening to me, but let me ask you the same question. Have you got the concept of this carrier sense multiple access with collision avoidance? Students, JSCOE students, I think girls are sitting on the first few rows on the left hand side. Are you getting the point? Are you getting the point? Just give me a like. Yes, thank you. This is Zoom like. This is big like. Thank you for that. So how many protocols we have studied from random access protocols? The very first one is a pure Aloha protocol, correct? Pure Aloha and slotted Aloha was second from Aloha network. Then we started with the carrier sense multiple access, where we had studied 3 persistence techniques, methods: I persistence, non-persistence, and third one is P persistence, where it was calculating the probability for sending the frame and again remaining probability for waiting time, as a waiting time. Then we started with the carrier sense multiple access with collision detection, where it was required where it was a requirement of the protocol that the length of the frame should be more than 2 TP. I mean total propagation time. Then and then only all the stations will be able to detect the collision and they will stop sending the frame. Again they will wait for some random interval of time and they will start sending the frame after some time. And the last one is a carrier sense multiple access with collision avoidance, in which 3 points are very important. The first one is interframe space time. You can see the diagram is in front of you. It will, after sensing the medium as a idle, you cannot start sending the frame immediately. You will have to wait for some time. That time is considered as a interframe space time. The second thing is a contention window, where it is going to select one random number. In our example it is 9. You can select any number. It will wait for that contention window size and you will have to complete the contention window, those time slots. And while completing the contention window, once you complete the contention window, if still if that medium is idle, then and then only you can start sending the frame. In our example, it is starting sending the frame. It has started sending the frame. This is how these three protocols works. Of course, this is a carrier sense multiple access. So IFS can be used as a as assigning a priority to the stations. You can assign the priority. There will be less interframe space time for higher priority machine. There will be high interframe space time. I mean more interframe space time for lower priority stations. This is how it works. This is a contention window I was talking about. The same thing which I have explained to you. It will stop the timer and it will restart it again. This is a flow chart, flow diagram for that. We'll not discuss the flow diagram right now. We'll directly go for the controlled access protocols. The second type of multiple access protocols. It was random access protocols where there wasn't any scheduling, there wasn't any means while accessing the medium. All the stations were accessing the medium at any interval of time. So there was a higher possibility of the collision. In this particular protocols in a controlled access, there will be a controller. There will be some, we can say, a means. There will be a rule who should access the media, who should not be accessing the media, and we'll be studying those protocols. Here we just have 3 points to cover. So within 15 to 20 minutes I will stop. Don't worry. In controlled access, can say in controlled access, the stations will be consulting to each other. Let's say there are 4 stations, then they will be talking to each other. Who should send the frame right now? Who should send the data? So as the name indicates, there will be a controlled access because they are asking each other that you should start sending the frame, then I will start, then station C will start, and then station D will start. There will not be any collision because every node in the network, they know that who is sending the frame right now. So it is been called as a controlled access. And under this protocol, the very first protocol is a reservation. Yes, this is the reservation protocol. We'll study the reservation protocol first. It's very easy, very straightforward. Have you studied this protocol before, student? ICOR, JSCOE, NTC students? If no, then say no. Yes, thank you. Thank you. You are so confident with saying no, but you are not that confident with saying yes. What's the issue? Sir, ती जरा window minimize करा. माझ्या screen वर. Yes, thank you. We have 4, sorry. Of course, there are 4 stations, but they haven't considered station 2. So right now you consider only we have 3 stations, or let's say we have 5 stations. For reservation protocol, let me tell you the theory first. Every station will be will be sending one frame, and that frame is called as a reservation frame. For this protocol to work, there will be a frame called as a reservation frame, and this is that reservation frame. And if you see in this reservation frame, there are 5 slots. Slot 1, 2, 3, 4, and 5. There are 5 slots. Why 5 slots? Because there are 5 stations in the network. If there are only 4 stations in the network, then there will be 4 slots. If there are 10 stations in the network, then there will be 10 slots in the reservation frame. So in our example, we have 5 stations in our network. So there are 5 reservation slots. Reservation under reservation frame. See, as the name indicates it's a reservation frame. Before you start sending the frame, you are making the reservation that I have a frame and I will be sending the frame. So if you see the diagram, this is station A, and as there are 5 slots, because there are 5 stations, the station A receives the reservation frame or will create the reservation frame and will forward it to the station 4, because there is a station 4 after station 1. But while sending the frame, it is replacing the 0 with 1. Do you see this 1? This 1 indicates station 1 has made a reservation. it was 0 if you see the previous reservation frame, and after it I mean station A receives the frame, one station receives the frame, it is making it 1. That 1 indicates it is making a reservation there, and then it will send the actual data. Likewise, all the stations will receive the reservation frame, and they will make their reservations. So the final reservation frame, if you observe this frame, station 1 has made the reservation, so 1 is there. There is no station 2 in between, so for 2 it will be 0. 3 has made the reservation, so it is 1. 4 has made the reservation, so it is 1, and 5 is not there, so it will be 0. So before you send the frame, before you start sending the frame, according to the reservation protocol, which is controlled protocol, controlled access protocol, every station will be making the reservation, and depending on the sequence in which they have reserved the reservation frame, all the frames, all the stations will be sending the frame, because of which there will not be any collision. Try to understand, this is a controlled access, there should not be any collision, and this controlled frame, reservation frame, is helping to remove the collision. There will not be any possibility of the collision because you are making the reservations. I think I have made it clear to all the students. Is it okay with the protocol, reservation protocol? It's very simple, will not waste more time in the reservation access protocol. I'll go for the polling. This is very interesting one. In polling protocol, very interesting point is there will be primary station and the secondary station. The primary station will be controlling all the secondary station. See, in our case we have this primary, and A and B are the secondary stations, and none of the secondary station will be given access to the medium. There will be only one node, that is a primary node, who will be having a control over the media. And there are two functions in this protocol. The first one is a polling function, and the second one is a select function. So there are two methods. There will be two possibilities that primary node will be doing. The first thing is, you have to consider the left hand side diagram. Primary station has sent a select message to station B. The select means primary node has some data to be sent to station B. Primary machine is going to send a data to machine B, and before it can send the data, primary machine has to select station B. It has to inform the station B that I am going to send some data to you. If you are available, then acknowledge me back. So the station B is acknowledging back to primary station that I am ready to accept the data and you can send me the data. Then primary station can send the actual data, and again B will have to B has to acknowledge the primary station. See what is happening in this protocol. None of the secondary station, in this case we have two secondary stations, station A and station B, and only one primary. None of the secondary station is having control over the medium. There is only one primary node, and who is controlling the media. Primary node will be only sending the data and will be receiving the data. In our first example, we have considered that primary has some data to send to B. Primary has sent the select method, select message to station B. If station B is ready to receive the data, then B will acknowledge the primary node that I am ready to receive the data and you can send me the data. Then primary node will actually start sending the data, and after receiving the data, B will have to acknowledge back to the primary station. This is about if A is having data to be sent to any other secondary name node. Not A, the primary node, sorry. But what if any secondary node has some data to be sent to primary? Then what it will be, how it will be, because secondary node are not having any control over the media, so they cannot send a request to the primary that I have a data and please, if you are ready, then accept the data or receive the data. It will be primary again who will be sending the messages to the secondary name node. Like if you have observed, you must have observed this thing number of times. When your teacher is delivering something, if you're teaching something to you people, then after explaining one particular point, your faculty will be asking questions to some of the students. Have you understand? Have you understand? Do you have any doubt? Do you have any doubt? If he is pointing out one particular student or group of student, that particular action is considered as a poll function. That complete action is considered as a polling message. That faculty is specifically asking one particular student. Let's say there are 60 students, and if he is asking every student individually, then he is doing the same way that polling function will be doing. The primary node will be sending the poll message to every station, every secondary station. Now in our example, it has sent it to A. It is asking station A that, do you have any data to send to me? If it is, then acknowledge me. If it is not, then acknowledge me with no data, no acknowledgement. If you have data, then acknowledge me, yes, I have a data. So A has no data, so NAC means no acknowledgement. Then primary will send the request or the message to B. See, this is a poll message. If B is having some data to send to primary, then it will send the actual data to the primary, and then primary will acknowledge back to the machine B, station B. So this is how polling reservation access protocol or the method works. There are two main functions, select and polling. Select is for selecting one particular secondary name node and sending the data from the primary node, and polling means getting the data from it. It's a polling, getting the data from secondary stations to the primary station. So this is how polling access protocol is working. It works. This is the last protocol that we'll be studying right now, and then we'll definitely stop. We are going to stop. This is token passing. Students, are you with me? Are you really with me, students? Do not pack up your bags and all. Just we are left with 10 minutes. I believe within 10 minutes I will finish with the stuff. So don't worry. I will complete my session by 3:30 only. I will not take any further. And really, I'm gonna thank you for bearing me more than 1.5 hours. The last protocol is a token passing. See, we are discussing controlled access protocols. I've been saying that there has to be control over the medium, because otherwise every node will start sending the frames at the same time and there will be a collision. So in token passing, there will be a token, and that token will be there, will be passed to all the stations. So let us consider our first diagram. It's a ring topology. Do you know ring topology, students? Hello, ring topology? You don't know ring topology? Yes, okay, thank you. It's a ring topology in which we have 4 stations, station 1, 2, 3 and 4. For the first time, station 1 will be having a token, and station 1 will send its data to whatever station it wants to send the data. This is the first thing. Let's say station 1 has finished with its transmission of the frame and all the data. Then station 1 will send that token to the next station. Now in ring topology, as this arrow indicates, it is in only one direction. If you see, it is in a clockwise direction. This is the direction in which all the data or the token will be traveling. So after one sends the complete data, one will send the token, one will pass the token to the station 2. Station 2 will receive the token. If station 2 has some data to be sent, then station 2 will send the data and will pass the token to station 3. So according to the token passing protocol, see, the meaning is, the theory behind this, the principle behind this protocol is, the station who is going to have a token, let's say this is a token. If I am holding this token, then I will be the only node in the network who can send the data. So there is no question of station 2, station 3, station 4, if I'm station 1, that they will be sending the frames. No, because I'm the only node in the network who is holding this token. So I will be only sending the frames. After sending the frame successfully, I will pass this token to next station, station number 2. Then station number 2 will receive the frame, receive this token. Let's say right now I am a station 2. I will receive this token. If I am having some data to send to one particular station, then I will hold this token and I will send the data. If I don't have any data, then I will, as I have received the token from station 1, I will hand it over to the station 3 because it's a ring topology. So this is how it is going to work as far as ring topology is concerned. It's just a game of token. The node who is holding the token can send the data. If you don't have data to be sent, just pass the token to the next machine. Now, what we have to understand only just the physical topologies of the network and how the token passing can be implemented in that. In the first diagram, you can see it's a physical ring topology. It works in only one direction. So there is a problem with this particular topology. If node 3 goes down, if node 3 goes down, if there it breaks the link in between 2 and 4, then 2 cannot send the frame to 4 directly because there is only one link from 2 to 3 and from 3 to 4. There is no direct connection from 2 to 4. So if node 3 goes down, we cannot do anything. The protocol cannot work. So somebody will have to go there and will manually work there to bring the machine back into the network. So this is the drawback, and to remove that drawback, they have come up with the double ring. You can see the outer line with the pink color in a reverse direction, in an anti-clockwise direction. So it's a auxiliary ring. It has been considered as an auxiliary link. The same ring is there, the first ring. The protocol is going to work with the same way. Every station will have to hold the token. And do remember, there is only one token. There are not number of tokens. There is only one token. The same token will be traveling through, going through all the stations. Station 1 will send the token to 2, then 2 will send to 3. Let's say 3 is down now. If 3 is down, then 2 will use its auxiliary way, that is dual ring, the second ring, to pass the token to 1, and then 1 will pass it to the 4. This is how it is going to work, and this is how they have removed the drawback of the first topology. The third one is a bus topology, bus ring topology, in which you can see that station 1, station 2, and station 3 and 4 are connected to one we can say one bus, that is one dedicated link. There is a tap, and by using that tap they have been connected to the bus. Let's say, but how the ring is being achieved is this is how, because A will be knowing, A knows that A has to send the token to the station 2 only. 2 has to send the token to station 3 only, and 3 has to send the token to station 4 only. They will be having source and the destination addresses of the next stations. So by using that, though there is no physical ring topology, just by using the source and destination addresses, they can form a ring. So the token will be passing in a ring fashion only, and every machine who is holding the token will start sending the frame. And the last one is hub, of course. This is a star topology. In star topology, of course, we are not going to have a ring topology, but how it has been achieved here as far as token passing is concerned, you can see that, let's say station 1 is holding the token, A has sent the frame, A has sent its data, A will pass the token to the station 2. So it will go like this, it will be received by hub, and hub will pass the token to station 2. Then station 2 will start its own data, then station 2 will send the same token to hub, hub will receive it, hub will forward it to the station 3, station 3 will again forward it to station 4. Let's say station 4 is down now. So how to continue with the protocol? Then in that case, this hub will come into the picture. Hub will continue the ring from 3 to 1 directly. It will not consider 4 if the link in between hub and the fourth node, fourth station is not working. If it is breakdown, then the hub will work, and hub will forward that token to the station number 1. So in token passing, as I said, there will be a token which says that if you are holding a token, then you can send the data. If you don't have token, you cannot send the data. You have to wait there. The node who is holding the token can only transmit the data. So this is how this protocol works. Actually, I was planning to cover the channelization too, but as it's a 3:30 already, I will not be continuing. We'll see some other day if it is possible. Then I'll meet you again, and then I'll try to cover this part and next some of the units if it has been scheduled. So we'll meet again. And this part is of course very simple: frequency channelization protocols, frequency division multiple access, time division multiple access, and code division multiple access. I was planning to focus on code division multiple access because this is very interesting part. This particular code division multiple access, but we'll see in some other day. This is frequency division and this is time division. So I'll come back to the original. First slide. In multiple access protocols, we have studied random access protocols, under which we have studied 4 protocols, and in controlled access protocols, there are 3 protocols: reservation, polling, and token passing. So I believe I have tried my, I have tried to explain the things in a easy way. So these first 7 protocols are very important. Channelization protocols will be used where cellular systems have been used. You can find this particular protocols in a cellular system: frequency division multiple access, time division, and code division multiple access. So from my side it is over. Thank you for bearing me for, I believe, it's 2 hours. Excuse me sir, slide गेलं ते escape झालं. ओपन करा जरा. Well, thank you students. Have you really understood what I have explained? So some of the part of the protocol, at least some of the part of the protocol. Well, number of students are laughing. For now, you just give me this sign so that I can understand if you have understood a little bit a part of those protocols. And I was going for the last slide. I have I was trying to give you the contact number and all. Yes, let me go to the last slide. Yes, where it is. This is my contact number and detail. Where it is. Yes. If you have any doubt, or if you, of course, respective faculties are going to cover the same part. But if you still need something with regard to the CFCA or PL2 practicals as far as CFCA is concerned, you can contact me. This is my contact number and the email ID is given to you. You can have a note of it and you can communicate with me. Well, once again, thank you very much for listening to me and giving me the answers in between. I also really enjoyed it. Thank you all, and all the best for your exam, which is in the next month. Thank you. Goodbye. Good luck.